From cybersecurity to positioning, the next speaker is a very close colleague of mine. We talk a lot about cross-country skiing, I think, Björn, every once in a while. So with that, please give a warm welcome to Björn Genborg, who will talk about positioning and demo that.
So, there was a couple of sessions that brought our mood into a different state. So now I'll try to change that to talk about some more basic things back to our mining environment and what we do in that scope. So I'll start to say that actually this session was supposed to be held partly by our colleague Momme, that he was supposed to do a sort of a live hack on how he can trick us on how to log into different networks on our phones, but we have skipped that part, and I will come back to the reason why we have skipped that in the end. Remind me if I forget about that. So anyway, I will talk a bit about underground mine localization systems. We have done a bit of various tests and pilots with various technologies, and I will tell a bit about those. So when you talk about localization, many of you know, are Boliden people, so you know that we already have a localization system in our underground mines. We are using this Epiroc Mobilaris localization system, which is based on that we track vehicles and people based on which access point they are connected to when being underground. This works well, but it has the limitations on the fact that it will only tell where we are based on the actual access point, which can be around 100 meters in the worst case on the localization. So what we are trying to do is to find out, is there technology out there that can make this better, more accurate, without spending huge amount of money? There are a bunch of different technologies that can do this. We will later today hear about what ultra-wideband based. There's a technology that can enable quite accurate localization or positioning down to virtual centimeter level, but it does require quite a lot of infrastructure in the mines to work. There are Bluetooth-based systems which sort of work the same way. They are low cost, but require a lot of infrastructure and maintenance of that one. There are Wi-Fi based systems, as we just mentioned. This Mobilaris system is based on that, but there are also some other technologies that we will come back to on that. There are LiDAR based systems, which use a LiDAR on a vehicle to localize on that. And there is also now coming systems that are based on vision. So I will go through a bit of these ones and show a bit of those tests as we have done. So I'll start to talk about LiDAR-based systems. So as you know, we have equipment from Sandvik and Epiroc, and they do locate themselves with LiDARs. So that is not a new technology. But we have also been looking at other sort of branches of that one, which are quite commonly in warehouses and manufacturing business, where they have been around for quite a long time. So basically, you make sort of a fleet. You can have a bunch of machines, 50, 100 machines in the same system, and they will locate themselves based on this LiDAR sensor technology. A nice thing with these systems that we have found is that they do dynamic updating of their map. So for an example from a warehouse, let's say you have a forklift driving around in the warehouse and you have new shelves coming up in that warehouse. These systems will automatically detect that, hey, now we see a new shelf in this place. The first time the vehicle will pass there, it will be a bit confused. Why is there a shelf there? It wasn't yesterday. But as more and more vehicles pass that place, it will sort of realize, crap, there is a shelf there. Let's update the map. And this is interesting because our underground mines have a tendency to change and update. That's sort of the basics of underground mining. One thing that we have noticed that is a problem with this is that since these systems are coming from warehouse and manufacturing business, they think 2D. They can basically just manage 2D. They can do 3D in handling floors, but I have not yet found a company that can do this in a constantly changing Z coordinate, meaning a decline going down into a mine. But anyway, we did a test of one of these systems from a company called Ident Pro. So what we did, we installed a LiDAR sensor through a magnetic fitting onto a roof. This sensor can be positioned either in the front of a vehicle, or in this case on top of the vehicle, or in the end of the back of the vehicle, because depending on how the vehicle is well, what kind of vehicle, you need to locate on different things. So the sensor can look in any direction. In fact, you could also direct it into the side. They would work at that time too. And nowadays, these companies are actually allowing you to buy the LiDAR sensor yourself. You don't even have to rely on the one that they are supplying, which could lead to that these systems become a bit cheaper in the future. So I will now start a video that is showing on how we did this test. So what we're seeing on the right side is the screen from the system, and we're seeing in the blue color how the recording of the mine. We did this sort of one run up and down. This is in Kankberg mine. So we did a run up and down, one time, and then from that single recording, we were quite surprised that it managed to locate itself at once. We are also surprised that it managed to do this even though the road is quite bumpy, as you see. This is a 2D LiDAR. Notice, it's a 2D LiDAR, not a 3D. So it has only scanned a line, but still it manages to sort of trace where we are. We can also see the fact that on the screen that now this guy who helped us doing this, he had to sort of construct floors of the mine. And that's why we are not seeing a constant sort of decline, a 3D model of that one going up there. We did test a bit to challenge this. We're driving close to one side of the wall versus the other, and it actually quite well can tell if you're close to one wall or another. We also tricked it by stopping at one place and sort of switching off the LiDAR, and then we moved the part and then switch it on, and it again managed to find its location. In the end of this film, in a few seconds, I think is coming up here, the actual recording of the map is sort of ending, and we can see how the system is trying then to continue to build the model, but at a certain state it will eventually run out of sort of backwards looking image, the model, and then it completely fails to locate itself. To mention, this is purely the LiDAR data, so there is no IMU, no accelerator sensor, or it's purely looking at how it has recorded the mine. We'll give it a few seconds more, it will reach the end. We can see now on the bottom of the screen, there is where the recording is ending or ended, and it will soon reach that part. And we will see how it will try to build the model continuing after the recording. So here it starts to build the new model from what you're seeing. But after running this section, it finally sort of completely stops in a second here. So it's dropped out. Anyway, so this is a technology that is quite interesting in that sense that we can, if we can find a company that can do this in true 3D, it could be possible to use at once. Another system that is kicking in nowadays is vision-based localization. Basically works the same way that you do use normal cameras to record your environment, and from that a camera on the vehicle will recognize where it is. So we ran into a company called Immersal, and we're a Finnish company, and we will sort of together with them make a pilot in the coming month to see if they can do that. So the technology based behind this is photogrammetry, and by a coincidence I can show another usage of photogrammetry to get a hint on how it works. I will start a video here. So what we're seeing here is a 3D model of the stockpile area of the concentrator plant in Boliden. This 3D model has been created by around 700 JPEG images taken from a drone that was flying for about 15 minutes over this area. So, and then processing these about 700 images into a software, it makes this model, which I think is quite astonishing on the detail, how it managed to do that. As you can see, I'm zooming into those rocks, and it virtually has been able to identify each rock in that pile based on photographs from, I think it was 110 meters height. So this is the technology that this other company is sort of utilizing, but they are doing this underground. They claim that it will work, even though that the light is very low, but they say a low beam light on a car should do the job. But let's see if that will work. Okay, back to Wi-Fi. So as said, we are using Wi-Fi now with the Mobilaris system, but there are also some other companies doing proprietary Wi-Fi based systems. One is called Coda Wireless, which is a company that we planned to do a pilot of, but of various reasons we have decided to not sort of fulfill that system. That company, Coda Wireless, they have a huge installation in a mine in Mongolia, where they have some 200 autonomous vehicles being localized with their system. So it seemingly works quite well, but once again, it's a proprietary system. Another proprietary system is a company called Sinar, which claims that they can do positioning from virtually any infrastructure from Wi-Fi. We did get a presentation from them. So what we're seeing here, this is a short video that will go several rounds, so you don't have to follow. So if you look at that green line up there, we will see an icon that is sort of moving along that line. This is a warehouse building in San Francisco. I don't know where they were, or these guys. So what is happening is that at this presentation, we were seeing how this guy was moving along that sort of area, and now he's placing himself in the corner. If you look at this super tiny up the sort of next to the lowest part, you can see this guy with a hard hat. He is the guy who is walking around here. And so we're sort of in real time seeing how he's located between those shelves, and he's sort of eventually ending up at that corner, so to say. This is very interesting. We wanted to sort of play with these guys, but we have actually, they are sort of kicking us out. They don't want to sort of play with us. They say they have other customers that they are focusing on more. So that was sort of a bummer. We had sort of planned to do this in one of the areas in our office to see if this would work. But more on Wi-Fi. So there is a lot of things happening in Wi-Fi in that sense that the Wi-Fi standard is changing all the time. So a recent name is 802.11az, a sort of standard that kicked out in March 23. Some AI told me yesterday. And what that standard gives is that you can nowadays, with any Wi-Fi client, like your mobile phone, when that connects to an access point having this newest standard, you can ask the access point of what is the distance to you. And then you will actually get a distance to each access point of this new standard. And this is, so once again, it's not really any software you need to buy, sort of. It's in the standard. So this, of course, we were very curious to figure out how does this work. So we did buy a handful of these Wi-Fi access points supporting this new standard, and we installed them in the mine, and we did some tests on this, and it worked really well, surprisingly well, I have to say. We managed to position ourselves very accurately. And and it works so well, so we, of course, would like to show this to you here and now. Let's see if we can make this. So what we are seeing here, I will actually do like this. So what we're seeing here is a model of this very building we're in, if you recognize yourself. So if we actually scroll out, we're seeing this on downtown Skellefteå. And this sort of black footprint is the footprint of the Sara Culture House. And here is this this room. What we can see here, there are 4 dots in the corners here, and this indicates the locations of 4 access points that we have installed up here in the back and in the up here. And what we're now seeing is that we have some colleagues from BI Nordic, the guys that helped us do this, which are now walking around in this room. So, well, you can run around a bit so we can see. This is basically how you will be traced in the future. It should be mentioned that this standard is based on the principle that you, as a client, can get this information from the access point, but at least right now, the access point cannot get the information from you. So what these guys have in their phones is an app which is sort of reflecting the measurements that the phones are getting and are telling that to a cloud service and then making this model on this one. But that is a quite simple app that is just reflecting that information. So this is made by our colleagues at BI Nordic, so they are the ones helping me out on working around here. And yeah, this we think can also be a quite game changer in short time if we can get this to do the job for us in underground positioning. That's basically what I was about to say, and then I can fulfill what I started. So I said that Momme's presentation in the beginning was cancelled, and that was simply of pure fear that his stuff that he was presenting would disturb this presentation, because he has a actual device that he was going to install here in the building that was sort of hijack SSIDs, hijack wireless networks, and we didn't really have time to verify that his system did not mess with this one. It would be sort of a showstopper if it didn't work. That's about what I was about to say, a bit shorter since we now didn't have Momme's presentation. Any questions on this?
Okay. I'm actually going to throw now. So.
Excellent. I really loved this demo, and I guess you kind of mentioned it, but just to be more specific, so I guess you need to upgrade your Wi-Fi hardware to be compliant with this standard before it works, or do the previous generations have some kind of beta version of this already?
Yes, it requires that the hardware, the access points are of a certain generation. Possibly some older ones can be updated with firmware. I don't really know that. But I think that, so what we have tested here is actually HPE Aruba stuff. That is not the standard that we're using in our mines. We're using Cisco stuff. But as I understand, maybe Anders can tell that we have noticed that the latest Cisco access points are also applying the standard. So we have tested this, so it works on the latest Cisco access points too.
Let's see how this goes.
Okay, more to answer your question about the access points and infrastructure. As Björn mentioned, this was the Aruba installation. But when it comes to Cisco that we are using, you need to go towards for the 802.11az. It's the 9130 access point, 9166, and some intermediary model called like 3165 or something, no, 63 or something like that. But you can search for that.
So anyway, as we do continuously update our hardware, so by time, knock on wood, with the supplier Cisco that we're using, we would reach this ability too.
Okay, I think we're going to wrap up there. Thank you so much, Björn.
Mm-hmm.